to go over the basics of LabView here. So first, let's open up LabView. Alright, and you can just close this. To start a new project, just go create project. And then you can pick a template or whatever, but for now we'll just do blank project. Actually, to make it even simpler, let's do blank VI because we're going to use one VI for now. A VI you can think of as being like a method or a function. Basically, it just is going to have a series of commands contained within it. And so upon creating a new VI, we'll see two different windows here, the front panel and the block diagram. The front panel is what the user interacts with the program runs, and if you right click on it, you can add various things to it, various indicators, etc. These are basically all things that the user can interact with, and so that's why you can add them from the front panel rather than from the block diagram. So let's go ahead and just add a string indicator here. And we can rename it if we want. Let's just call it, let's just leave it blank actually for now. And then we can look on the block diagram and we see that the indicator actually showed up here as well. And so now, let's just go ahead and make a simple program here. So you can see again, right clicking, we get this menu, which can also show up over here. And let's go ahead and add a string constant. This is just some value. It's not going to be accessible from the front panel like this indicator here is, but it can just store some value for us. So let's have it store the string hello world. And then in LabView, to make connections between different things, just look for this wiring here. And so we're going to wire from this constant to the indicator, and that when the program runs will transfer the data from here to here. Once you run the program, all you have to do, press the run arrow here, and we can see program runs and displays hello world after transferring the data. Alright, great. So now let's try a slightly more complicated version of this program. And to do this, we're going to start over here. We're going to have, instead this time of just an indicator, we'll still have the indicator, but now let's also have a control. A control is something that the user can input things into while the program is running or before it runs, and then indicators on the other hand are just intended to show data. So now back on the block diagram here, let's wire from string 2 to the original string, and now this does the same thing that just having the constant there did, except now so we can see if it runs, because we haven't entered anything into string 2, nothing gets transferred. If we try entering hello world again, when we run it, then hello world transfers, and if we change it, run it again, then the string updates accordingly. So that's the basic idea of how data is transferred in LabView. One thing you can do if you're having trouble following all the data transfer is you can do highlight execution here, and then when we run it, we can see hello being transferred from string 2 to string 1 along the wire, and that'll slow down the program, especially if you have a lot going on, but it makes it easier to see what's happening. Now another thing we can do here is we can add wait time here, so that if we had a lot of things going on in this program, which of course we don't, it would just be a little bit easier on the memory. So that's just located right here, timing wait, and that all we have to do now, we just wire a numeric constant to the wait time, and this is in milliseconds. So let's say we want it to wait for 1 second before doing this, so that's 1,000 milliseconds. But now we're actually going to see a little bit of a problem here. So if we change the string, it's still not going to wait, and that's because in LabView everything happens at the same time. So if we highlight execution here, we'll see that the wait time and the string gets transferred at the same time. So the wait actually happens after the string is transferred. So to fix this, what we're going to need to do is create something called this case, sorry, not the case structure, the sequence structure. So let's try just a very basic flat sequence structure here. And so we're going to want here to add a couple frames. So let's have 3 frames here. So in the first frame, well actually, you know what, let's make it easier. Let's just have 2, sorry. So let's just, flat sequence and 2 frames. So in the first frame, we're going to have the wait time. And basically what happens is now when the program runs, it's going to look at the sequence, and it's going to run this part of the sequence first, then this part. And just as an additional demonstration here, so if we wanted to say have some reference to the string over here, so something happens to the string, and then after the wait something else happens. So for example, we can actually demonstrate this. So let's get another string constant, and let's say by default we want the string indicator to just be an empty string. And then after this 1 second wait, you want it to have whatever value is in string 2. And so that means we're going to need to put string 2 in here. And that means we're actually going to need to reference this variable in more than one place. So to do that, we're going to go to create, property node, and value. And we can see that by default here, this value is being transferred from the indicator to something else. We don't want that, though. We want to write to the indicator. So right click, change all to write, and then wire from string 2 to string. So now when this runs, it's going to, by default, just clear out whatever is down here in the string. And then after 1 second wait, it's going to transfer this data from string 2 to string. So let's see what happens here. Let's just, for the sake of example, change that again. So we can see it gets emptied, and then after that, highlight execution, it gets transferred, and we see it. And if we turn off highlight execution, of course, that'll run in actual time, so after 1 second, it just pops up. So that's getting slightly more complicated here. Now let's try a demonstration of a function. So there's all kinds of functions in LabView. You can see just by looking through, pretty much it calls all these functions, but really some aren't. Like just addition, that's not really a function. It's just kind of a basic programming idea. But most of these are functions. And one I can just demonstrate here is concatenate strings. So suppose that instead of just transferring directly from this string to the other string, we wanted to actually concatenate this with the second string. So let's just click on that wiring here and delete it. And now we're going to need to concatenate. Let's make this a little bigger so it's easier to see. We're going to need to concatenate string 2 with our other string. And actually, sorry, let's put this. So it's going to do them from top to bottom here. And if you need to, you can say like add input or remove input if you wanted to concatenate more than just 2 strings. But anyway, it's just going to concatenate all of them from top to bottom. So let's add another string constant and call this, let's say, data. And now we've concatenated the 2 strings, and we can send it to the indicator. So now this hello will be prefixed with data after that 1 second runtime. And so that is just an example of one function. Basically, if you need help knowing what a function is, because there are a lot of them, just go to help here, and it'll pull up a Chrome, and it'll pull up the web page, and I'll give you help with that. But yeah, for most things, there actually are already functions for pretty much any basic operation, and you can search from here. Sometimes you'll need to create your own function, and that'll be covered later. But for most purposes, at least for simple ones, you can just look up a function and use that. Alright, so now let's go to a slightly more complicated example to finish off. And this is going to involve a couple more ideas here. So the main idea I want to do is a while loop, and this is going to make the program run until it reaches the stop condition, which you can set here. And by right clicking on this, we can just really easily create a control. That's just this stop button here, which you can move into the center. And that'll just stop the program when the user presses stop while it's running. So that's a pretty simple way to end a while loop. And usually while loops are used to have a program run continuously rather than just go through some sequence and immediately stop. And you can also use for loops and other structures here. The other one that I want to point out is the case structure. Unlike the while loop, this won't run forever, but instead it takes some input and it just does different things based on what the input is. So we're going to try using both of these together to finish this tutorial out. And what I want to do is I want to make a program that displays how many seconds the program has been running. And then depending on whether it's been running for an even number of seconds or odd number of seconds, it'll have an indicator to indicate which one of those it is. So we already used timing, and there are more than one ways to do this, but just since we've already used this function here, the wait function, let's go ahead and use that again. So again, we just go create a numeric constant, and we're going to have it wait 1 second every time it goes through the loop. And so that'll make it easier on the processor, and that's also how we're going to keep track of how many seconds the program's been running. And of course, this isn't going to be a great approximation because it does take some very small amount of time to go through the loop, even excluding the wait time. So it won't be a perfect approximation, and if we wanted to make this a little bit more complicated and better, we could actually use a different function here. Is get date and time in seconds. And then we just have to store the initial date and time that the program was running and just compare the current time to that time. But for the sake of simplicity and to demonstrate the use of this case structure, we're just going to do it this way. So now we're going to wait a second before updating. Well, we'll need an indicator to update. So let's create numeric indicator, and we'll call it seconds running. And yeah, of course, by default, that's going to be 0. And then for each iteration of the loop, we're going to want to add 1 to this indicator. So here's the function under numeric, just increment by 1. Now the problem with this, we can see, is that it takes an input and an output. So we know what the output's going to be. It's just going to output to seconds running. And actually, we're going to want to take our input as second runnings too. So again, to do that, we're going to go into create, property node, value. And this time we actually do want to write from the value to something else. Sorry, to read from the value and send it to something else. So now we're going to just add 1, 2 seconds running every time we go through the loop. And then we're going to want to have this indicator. So let's make an indicator, a Boolean indicator. And we can just have anything. Let's do that. So we'll say if it's an even number of seconds running, or let's do odd number of seconds running, then the indicator is on. So odd seconds running, we'll call it. Alright, so we're going to put this inside the case structure. And the thing is, we're going to reference this in both the true and the false, because depending on whether or not it's even or odd, we're still going to want to change this indicator. So we're going to need to create another property node, and this one will just go in false, so we can reference it from 2 places. We're going to need to change this to right. Now for this, the case selector, we're actually going to need to create yet another property node. And rather than just wire it straight from the value to the case selector, what we're going to need to do is determine whether or not it's been running for an odd number of seconds. So we're going to go into numeric here, and there's actually a function that we can use to do this. And basically this is the mod function, which, sorry, I'm not immediately seeing that. Sorry, let's search for it. Alright, so the next thing we're going to need to do is to add something here to the case selector so that we know whether to go into the true or the false case. And what that's going to be here is actually probably the best way to do this is to actually use the case selector itself. So we're going to create, oh sorry, not the indicator itself, I should say. So create yet another property node here. And rather than wire, well actually that we can do that, but I want to demonstrate the use of one more function. So the not function, and again this isn't necessary, but it demonstrates the use of a different kind of function. So this will take, if this is true it'll take false, and false will take true. So that means that if we start out, we're going to start out false because we started at 0 seconds, which is even. So we're going to start in the false case, but then we take not. So then we go to the true case. And then when we enter the true case, the first time we're not going to want to do anything because we want it to be off. So that means that we're going to need to set this to a false constant. And if we enter the false case, we're going to need to do the opposite, which is set it to the true constant. And then every time we go through the loop, this will enter the opposite case because we're changing the value of this odd seconds running every time through the loop. So now we can see this program, our final program here. Let's run that. So alright, and we can see we actually have an error here. It is incrementing correctly. And the stop button we saw works, but the indicator is not turning on and off. And the reason for that is because using this not function, I got a little bit confused. And using this not function, we actually did it backwards. So there's two ways we could do this. One is just click on this and click on this, and that'll just reverse the order. And we can see now that it works. Whoops. Goes and now because we have to set this back to 0, and that would be a different part of the program. We'd probably use a sequential execution structure actually to just do that once the while loop has run fully, but that won't be necessary because at least now I've got it working, and for this simple example that'll suffice. So that's basically just a simple demonstration of the main ideas of programming in LabView.